Now let us look at the statistics. The empirical mean and standard deviation for each variable plus the standard error of the mean. These are straightforward from any basic statistics course. What is naive standard error as opposed to time series standard error? Um, the time series standard errors are calculated after adjustment for autocorrelation because there is going to be correlation between the data at different points in time. Those correlations are eliminated in getting the time series standard error. Naive standard error, on the other hand, is standard error based on all the data without any correction for correlations that may exist over time. Sample statistics and observed values. For edges, mutual ties, gender, and absolute difference in the per capita income. There's a difference and test statistics and p-values. If you look here, the p-values are rather high, which suggests that the model is not a great fit. So you may like to fiddle around with the model. Same here, the p-value for the overall chi-square is also a bit high. So the model is not a great fit. Then it gives the sample statistics cross correlations between the four variables and others. For example, between edges and mutual, edges and gender, and so on and so forth. If you look at this, you see that the correlations are rather high. That suggests that there is a relationship between edges, mutual ties, gender, and so on and so forth. Since there are relations between these, maybe you need to change the model, eliminating some of these variables or adding other variables. Let us look secondly at the summary of M1. To get the summary, all you do is at the R prompt type summary within parenthesis M1. It gives us the formula first. This is the model that we used to run ERGM. The model variables, independent variables, are edges, mutual ties, gender, and per capita income. Next, it gives the Monte Carlo maximum likelihood estimators. For the edges for mutual, non-detached for gender, and node match gender, and the per capita income. These are the estimates of the parameters in the ERGM model. Remember, the ERGM model, the parameters appear in the exponent. So these estimates will need to be adjusted. That is what we are going to do next. So the estimates above are the parameters etas that we saw in the class last week. To convert these to exponents, we L apply M1 1 and exponent that is we raise to the power e. The coefficients we get are the following. These are the actual parameters that have been estimated by running ERGM and the using MCMC algorithm. A1C, Akaike information criterion, and the BIC, Bayesian information criterion, are used to select from amongst models. Here we have just used one model for estimation. In most real-world applications, you run a whole bunch of models, and then you compare the Akaike information criterion or Bayesian information criterion. Let us now study the last part, which is the trace and density plots. The trace and density plots of the trace plots are given on the left hand side, that is these mixing, and the density plots are given above earlier in these. These are the density plots on the right hand side and the trace on the left hand side. Usually when the plots look like this, that means the mixing is good. If the mixing is not very good, it looks rather jagged, like here on the right hand side. Right hand side. You can compare these plots here with the plots that we got in actual running of the tutorials. What is mixing? Mixing is the movement around the parameter space as you run the different iterations of the simulation. So these are the iterations on the x-axis, and the parameter space is in the y-axis. Each iteration, the parameter estimate keeps fluctuating. If the fluctuations are somewhat like on the right hand side, that means the model hasn't worked out very well. On the other hand, if it is on the left hand side, it has worked out reasonably well. If you see the plots, we do not have any bad mixing here. So the trace, it seems to have worked out fairly well. This is the way in which you interpret. You look at the values of P, you look at the mixing, you make sure that the density of the various variables, density plots of the various variables are somewhat normal. And depending on the p-values, you fiddle around with the models. This concludes this particular short tutorial. Thank you.